y equals x squared minus 3. Now, I want you to predict for me what this is going to look like. What does an x squared graph look like? Smiley face graph, a positive x squared. And what's this 3 going to do? -3. It's going to drag it down 3. So I should know before I even do it, it's going to look like that. All right, so let's do some predictions. So well, let's undo that.
Wait,
What do you mean do your best Aussie accent? All right, guys, focus. Hey. All right, so we're going to substitute these values of x into this equation and put in the responding y value. So what is -2 squared? 4. What's 4 minus 3? 1. So what's -1 squared? 1 minus 3? -2. 0 squared? Minus 3? 1 squared? 1 minus 3? -2. 2 squared? 4 minus 3? 1. 3 squared? 9 minus 3? Okay. So now that I have a bunch of points, I'm going to put this on. Let's use a straight line graph, shall we? No, why didn't that work? All right, so on the x values, I only need to go down to -2 and up to +3. So that's all I'm going to draw. But the y values, I only need to go down to -3, but up to +6. So 1, 2, 3, 1, 2, 3, 4, 5, 6. Now what I'm going to do is put a bunch of dots in. So where -2 is x, y is 1. Where x is -1, y is -2. 0 and -3, 1 and -2, 2 and 1, and then 3 and 6. Now, exactly. All right. So one of the things that you need to do in this type of graphing is do this idea first, where we predict what it's going to look like. Because if you put your dots in the wrong place because you've accidentally done a wrong calculation, you should be able to see if this dot was accidentally down here somewhere, I'd be like, well, that one's wrong. It can't be true, right? So this is my lovely smiley face graph. And if I accidentally had a dot that did not fit that pattern, I'd know I did it wrong and I have to have another go. Go back and check it if one dot is out of place, because that's what predicting what it's going to look like is going to do for you. All right, so let's do a harder one. We already know what quadratics look like, but let's do one where we're not used to doing it, because that'll test us. So if I do y equals 2 over x plus 1, what kind of graph is this going to be? Exponential? Reciprocal, okay. Which looks like what? Right. So it's going to look like this. There's no negatives involved, so it's going to look like this. The biggest mistake, guys, you need to pay attention. This is a super common mistake. The most common mistake people make is trying to join these two bits when they're joining the dots. So I'll show you what normally happens, but first let's actually make a table of values. Let's do that. Okay. So we are going to substitute all these x values in and see what we come up with. All right, so 2 over, if this is -3, -3 plus 1, -2. What's 2 over -2? -1. Okay, anything divided by itself is going to be 1, but one of them is negative. All right, -2 plus 1, -1. 2 over -1, -2. All right, let's do it again. What's -1 plus 0, plus 1? Okay. Okay, does that mean I get to put 0 here? Why not?
You can't divide anything by
Good. You can't divide anything by 0. So I want you to think about what this graph is. There is a gap in this graph. Isn't this the gap? So when the bottom of the equation equals, hey guys, lots of people talking. When the bottom of the fraction equals 0, that is the asymptote.
Ooh.
All right, so x equals -1. That's what this line's going to be here at -1. All right, let's put 0 in there. 0 plus 1, 2 over 1, 2. 1 at the bottom, 1 plus 1, 2 over 2. All right, 2 plus 1, 3, 2 over 3. Okay, this is 2/3. Now it gets annoying. It's fine. It's okay if we have fractions. It's just a little bit unpleasant. 3 plus 1, good. So this is 4, 2 over 4 is 1/2. Whoops, I said 1/2 and then wrote 1/4. All right, so if we have fractions, that's fine. Let's try and draw it.
That's crazy. God.
Are you picking on me? Be nice.
Guys,
All right, so I only need to go from -3 to +3. 1, 2, 3, 1, 2, 3. Wow, that's terrible. We get the point. Shut up. All right. Oh no, there's it's the screen. It's the I thought you were picking on me. I thought you were being mean to me. All right, so for these ones, we don't have to go up much at all. We're going up to 2 and we're going down to -2. I thought you were being mean to me. My bad. All right. Hey, in my defense, you are being mean to me. All right, so -3 is -1. -2 is -2. This we decided is our asymptote. Okay, so then we have 0 is 2, 1 is 1, 2 is 2/3, which is sort of here-ish, and 3 is 1/2. So can you see how this is forming this shape? Now, this one you've only got 2 dots, but you should still be able to see that it's going to do this. And because we said that's our asymptote, right? So make it a reflection. We should see the rough shape that it's going to form. So that's why you need to be able to predict what it's going to look like. And whenever the bottom is 0, it's your asymptote, right? 0 is the asymptote. All right, do you get what we're doing? It's just table of values graphing. Yeah. There's lots of ways you can make it do that. It's very complicated. If you combine all sorts of things, you can make it do all sorts of crazy things. All right, so today we are doing 18.1 and 2. You do not have many questions to do because graphing takes time. It is time consuming, but it is important that we practice graphing different shapes.